Good morning, students. Today we are going to study about lignins. Lignins is a product obtained from natural sources. So the term lignin was first introduced by the scientist Haworth in 1948 to describe a dimeric phenyl propanoid. So phenyl propanoid, if we draw the structure, it is this is the structure of phenyl propanoid, and in lignin two phenyl molecules are attached by the central carbon, and central carbon or C8. The central carbon, they refer to the central carbon of the chain, and when we give the numbering we give it in such a way: 1 2 3 4 5 6 7 8 9. So that way we do the numbering. So the eighth carbon, this C8 carbon, two units like this, they both are combined to each other by this C8 carbon. Lignin is not a single compound, it's a class of compound. So this is the parent structure. This is the phenyl propanoid parent structure. It could have any number of substitution. There could be different kind of substitution. So the lignans is a dimeric phenyl propanoid, and it's actually a class of compounds. Okay. Now, what the next sentence is: lignans are a subgroup of non-flavonoid polyphenols. So, similar to lignans, there is a category called flavonoid. There are fatty acid. There are terpenoids, steroids that we will be discussing in the coming classes. So, what they say is lignan is a subgroup of non-flavonoid polyphenols. They are flavonoid which have polyphenolic secondary metabolites. It's also a class of compounds, and other than flavonoid, the remaining polyphenols are called non-flavonoid polyphenols. So it's one of the subgroup of that. These lignans are widely distributed in the plant kingdom, being present in the more than 55 plant families, where they act as antioxidant or as a defense molecule against pathogenic fungi and bacteria. So what they do, what's their purpose in plants is they protect the plants from pathogenic fungi and bacteria. But these lignans are found useful for the humans also. Like some of them have some medicinal properties. Some of them can be further modified to prepare something that could have medical properties. So that way lignans are important. Now we see the structure. This is phenyl propanoid unit that I've already told you, and some places you will have a beta beta dash bond. So this beta beta dash bond is, if you see, this is the beta from this chain. This is alpha beta gamma. So this position is beta position, and if you see a lignin unit, it's a lignin structure, the most basic lignin. These are bonding from the C8 for one unit and C8 dash for the other unit, or you can say beta and beta dash. There is one more term that you might find: lignans and lignins. So the basic difference between lignan and lignins is of molecular weight. Uh, lignins are also obtained from polymerization of phenyl propanoid unit, but in case of lignin it's a dimer. In lignans are dimer, or lignins are polymeric. they have more than 2 units. So that's why they are called lignins. So that's the very basic difference between lignins and lignans. Now this I have already told you their basic chemical structure consists of two phenyl propane units linked by carbon-carbon bond between central atoms of the respective side chain, position 8 or beta, also called beta-beta dash bond. So this I have already explained. Now in these cases the dimer are called neolignins. When a dimer is formed, that a term used is neolignins, and hence their chemical structure is referred as C6C3 whole twice. That represents C6 is this aromatic part and C3 is your side chain. So this is C6, this is C3. So for lignin they write C6 C3 dimer. So this is the this is how they refer to the chemical structure, and they included in the phenyl propanoid groups as well as their precursor. The precursor of this is the hydroxycinnamic acid. If you have to obtain the lignin or phenyl propanoid group, um, you have to synthesize it by hydroxycinnamic acid. So if this hydroxy group is absent, this one, then it is cinnamic acid. Okay, and if if we substitute OH on the second position, then it becomes hydroxy cinnamic acids. Okay. Now lignins can be found in more than 60 families of vascular plants and have been isolated from different plant parts, exudates and resins. It's not only obtained from the plant parts, it can be isolated from exudates and resins also. If we talk about the biological activity of lignins, then we can say some of them have antiviral properties, anti-cancer properties, cancer prevention is there, anti-inflammatory, antimicrobial, antioxidant, immunosuppressive, hepatoprotective, osteoporosis prevention. So like they have very wide range of biological activity, and some of them can be useful in cure of very um, harmful disease like cancer, osteoporosis, so all those things, hepatitis. Now based on their carbon skeleton cyclization pattern and the way in which oxygen is incorporated in the molecule skeleton, they can be divided into 8 subgroups. So basically based on the structure, we divide lignins into 8 subclasses. The first is furofuran, second is furan, third is dibenzyl butane, fourth is dibenzyl butyrolactol, fifth is dibenzyl butyrolactones, sixth is aryl tetraline, seventh is aryl naphthalene, eighth is dibenzo cyclooctadiene. Now if we see their structure, you will be better understanding these things. If some lignin have this kind of structure, then the subclass of that will be furofuran. It's actually two furan rings fused together in such a way that the two oxygens are all on the opposite side to each other. So this furan you have already started. Dibenzyl butane. If you see, this is the structure similar as the basic lignin structure we were writing. Only difference is instead of having a hydrogen here, it has a CH3. Okay. Now benzyl butyrylolactone. So this is the structure of lactone. So dibenzyl butyrolactone. If you have dibenzyl butyrolactone, then there will be OH group instead of double bond O. So this is the difference in both of these structures. Then comes the tetraline. Now tetraline, we have aryl tetraline. That means along with this tetraline, we will have some aryl group attached to it. Similarly, aryl naphthalene. So some aryl group will be also there along with the naphthalene structure. And last was dibenzocyclooctadiene. So this is the basic structure of dibenzocyclooctadienes. All right. Now, how they exist in the nature? Lignins are not present in the nature in the free form. They do not exist in the free form, but they are generally linked with some other molecule, such as uh, glycolated derivative. That means some saccharide or some uh, protein will be attached to the lignin. It won't be available freely. If we talk about the most common lignins, there could be sacchoisolerycresinol. This is the most abundant one. Lerycresinol is second one. Then pinoresinol, metaresinol, 7-hydroxy These are some of the common lignins. Okay. Now, podophyllitoxin is a naturally occurring aryl tetraline lignin. So we have already seen the structure of tetraline. If we go back, this was the structure of tetraline, and podophyllitoxin is one of the aryl tetraline lignin, and it is one of the most important compound in the lignin family due to its high toxicity, and currently it is being used as antiviral agent. It is obtained from a plant Podophyllum, and it belongs to Berberidaceae family. This family gives us lot of other substances also, which are used to treat the cancer. Okay. So podophyllitoxin is a mitotic toxin, and its derivatives are used to synthesize chemotherapeutic agent. So chemotherapeutic agents are nothing but the agents used to treat the cancer. So this is one of the example. Now if we talk about the food rich in lignin, then there is flaxseed, alsi we call it in Hindi. Sesame seeds. Sesame seeds are जो तिल होते हैं. There are two types of til, black and white. छोटा छोटा होते हैं. And whole grains. These are found rich in lignins. Now flaxseed की अगर हम बात करें तो it has mainly sacchoisolerycresinol that we discussed, that it's the major constituent of lignin. But there is also resinol, pinoresinol, metiresinol in good quantity. And some of the quantity is also found in sesame seeds and whole grains also. Now, if we see the structure of these five different lignin that we have discussed, this is sacchio-isolericeresinol. If you see the parent structure, you can easily find this is the benzene, and this is 1 2 3. This is your, actually it should be hydrogen, not OH. So 1 2 3. This is basically the parent phenyl propanoid structure, and it has some substitution, one hydroxy group, one methoxy group, another hydroxy group here. So that ways it is having substitution. If you see the other parent chain, it is this benzene structure, 1 2 and 3 carbon. So that this is sec-iso-lariceresinol. If you see the structure of lariceresinol, it has a cyclization. So 1 2 3 1 2 3. So that way cyclization is happening here. This gets cyclized and a water molecule gets released and results in the form of lariresinol. If you talk about pinoresinol, then again this structure we have seen. Only difference is the middle bonding or or the way that it gets cyclized. If you see metaresinol, then again the only difference is here. It is your lactone part. If you see 7-hydroxy metiresinol, then you have a difference of OH group is being attached here. Only difference between the metaresinol and 7-hydroxy metaresinol is on the 7th carbon there is a OH group attached. So these are the structures. In the next class we will study about the biosynthesis, or you can say biogenesis of lignins. Thank you.